welcome to another OTT here at YPrompt. Today is November 2024 and I will talk about the AI agent. We will discuss some AI patterns to create the agent. We will cover as well some multi-agent approach, graph improvements, and as well our journey about the GraphRAG as well. Probably we'll split the presentation into 2 or 3 sections because probably it's too much information to. So let's see. Let's start. Well, so I created for you like a mental map where I was translating like some ideas, the information that we were retrieving during these days. Created like this kind of mental map that I want to show. As an introduction, I created here a kind of reference where we will see some of the building blocks of the diagrams that we will show during the presentation. We will cover this in a brief, and then we will see in the left part of this vertical line we will see architectures diagrams. On the right side we will see some sequence diagrams about how the request is going through the different elements in the assistant, and on the right part we will have some notes and screenshots that I want to show you. Well, so the plan is to talk about the agent or an assistant, and as well about some elements that we will need to at least to understand like a general way. So these are the building blocks to create like agents, and I split it in two main parts here. We have passive agents that I called, and then we have the autonomous agent. The main difference here is that, as you can see, there is not an arrow here between the actor and the human which is interacting with the agent. So the AI engine will work autonomously. So this is not a pattern that we will discuss here, but it probably will be a future approach, because looks like all the research and the latest implementations are trying to create a kind of autonomous agents. So we'll be focusing on the passive agents. So here we have on the left side some sort of input of the engine. So we have a human that it's interacting with the agent. By the way, in the presentation, agent or assistant will be the same. Or we can have like an event. The event could be we receive an email, or we have some information we extracted from our system, and the information will hit some request to the assistant and will do something. And the assistant or the agent is the one that will use the LLM in order to synthesize some action or some response. And the agent in this context of like enhanced agent can have like a knowledge base. This knowledge base will be some information that we provide to the agent that the agent doesn't know, which could be a private information or some current data, new library, or information that is private for companies, so it's not public, so we need a way to include that information. In these 3 main building blocks we will have some options, a way to improve how the agent work, how the LLM work, and how the knowledge base work. But so far these are the main components and places to make changes and improvements. Okay, so let's start from the very basic one, when we have an actor which is interacted with an LLM. LLM, as you know, these days are examples of LLMs are like GPT, Claude, Gemini, Llama, and etc. So here we have an LLM that we can ask to some questions or share some data, and the knowledge base LLM will create a response for us. and it's working incredible. So we want to, in this context of the LLM, here in this sequence diagram, here we have the user who's sending a request to the LLM model, and the LLM model create a response, synthesized a response, and send it back to the user. This is the main experience that all the people have when interacting with an LLM. So here we have some notes that I want to share, and maybe some concepts, because here what we are doing is to send like text data to an LLM model, and the LLM model on their end, what it's doing is to translate the information to embedding, which is the kind of information that they can process. Here we will have a transformer. The transformer is part of the LLM, where the transformer, what it's doing is this transformation from text to embeddings, and the transformer has like the main characteristic that the transformer has are the attributes or the parameters. It's common that when you want to download a model or to use it, you will see that the models have like different sizes. The size is correlated to how complex the model can understand some information. So as much parameters, the model will be bigger and can understand like a more complex scenarios, and as well they will need like more resources to run, probably more GPU. So when we are talking about parameters, in this example, it's like it's like an old approach of a neural network, where we have like these arrows. The blue ones represent like the neurons, and the arrows represents like the connection between the neurons. So the weight all these are the 9 parameters that this particular very simple model has. But it's just an example, because nowadays the models, the smallest model has like 5 or 7 billion parameters. But it's just a concept, right? So we want to understand when we are talking about parameters and when we are talking about context. So in this layer of the LLMs, we have like several options, and what I want to show you here, like there are several companies that they are creating their own models. The models can be private or public, so that means that you can download the model or not and run it in your own infrastructure. And as you can see in the latest column, there is a context window, which is information that the model can manage. So as you can see here, starting from GPT-4o, it has like 8,000 parameters, and nowadays we are in 100,000 or million thousand or 100 million thousand of tokens. So this is the latest one, the Magic. I am not sure if this is it has like a public accessible, but what I want to show you is like the tendency about how fast these models are changing. So it's related to the conversation that we will have today, because of the limitation that the LLMs used to have, and the limitation in the context window they can manage, and as well in the knowledge that they were trained. The industry creates like different patterns, or there are several researchers or papers about how to manage and a big context, new context of the LLM, in order to deal with this kind of limitation. But nowadays there's a tendency where the context window is like much higher. So at some point, maybe some of these patterns, probably some of they will be deprecated at some point because of the new capabilities of the new LLMs. But probably it's important to understand how can we build this building. This our example is a screenshot comes from the Olama page, Ollama works as a repository where we can download like public models as Llama 2, and here you can see Llama 2 is one of these LLMs, and it comes from different sizes, 7B, 7B, and these are the parameters that they were trained. And as you can see, as it has a relation between one has like 7 billion, it has like 4 gigabytes, and the 70 billion has like 40 gigabytes. Some note that I want to share here is like if you want to run the model, you need to have in your computer a GPU or anywhere that you the model. For Mac users or MX Apple users, probably you can run it like these two types of model. It's to run your local computer, and you can avoid to monitor you to do your experiments. Okay, so this is the first node, and we want to talk about agents. So here are some architectural diagrams. Here we have an actor, and instead of interacting directly to the LLM, we'll use an intermediary, which is an agent. We'll have like instructions about how we want to use the LLM. Typically here we have a profession, we have instructions, we have examples, we have like detailed instructions about how we want to retrieve data to the. And here we have another option where we have our agent, and we want to include or extend our functionality, adding like storage layer. The storage will be related to store like a new knowledge base and known by our LLM. We have as well a conversational DB where we are storing a long conversation that we are having with our LLM. And as you can see here in the context of the assistant can use like in this case a private LLM which lives outside of our infrastructures like GPT-4, or we can include the LLM in our resources where we need to have a GPU enabled here. So these are like the main options. We have an agent, we have the LLM. The LLM can be private or can be public, so you can download it and use it in your own data center. So here the assistant, when we are sending a request, the assistant is the one that will forward some request to the LLM, and the LLM will respond back, and answer will be processed to send it back to the user. So how does it looks like? At the time the user is sending a request to the assistant, typically we will have a system prompt. The system prompt looks like this. These screenshots come from Longsmith Hub, where you can download like a set of prompts. They are pre-created by different users. So in the prompt, what I want to show you here is like it has like a detailed instructions about how we want to extract or do some action, and then it has like these placeholders where we are typically sending some inputs that they will usually change. For example, in this prompt, what it's doing is like giving a transcript of a recording from YouTube. What it's creating is it wants to create an article, and these are the instructions to how we want to create an article. So the input will be the transcript, and these are the instructions. So LLM will take like the transcript with the instructions as a single request, and so this information about all the instructions and the transcript will send to the LLM, and the LLM will send it back. So what we need to be aware is like this is the context windows that we are talking about here. So this process can be as complex are as big as these context windows in our LLM side. So for recording, maybe this could be something doable, but other time we want to, what about if we have like a pretty extensive knowledge base with books or all internet knowledge, how we can deal with that other. So that is one first question that we have here during this, in the context of this kind of assistant, we have like different strategies. In this case, we have like a custom task that needs to be done, right? We have the instructions and we have the data that we want to ingest to the assistant in order to do some action to create an article in the example. Other approach will be to have a conversational. The assistant will need to deal with their conversation history. So as well, in some of the prompt, of the system prompt, we will need to ingest the conversation. So as well, the conversation will have some impact in the context. So we will need to deal with strategies to manage like long context conversation, probably. As well, we can have like multiple interactions with LLMs. In this case, this is a pattern in the context of a context-aware assistant. The context-aware assistant is in the context of a conversational assistant, and what it's doing, it has like two main parts. The first one is to give like a context to each question that the user sends to the assistant, and then to create the answer. So in this case, what the highlight here is like we have two calls to the LLMs. First, we are doing is to give context to a question. So given a question and a conversation, the question will be reprocessed or in a way to create like a question with a more meaningful data in the around the conversations that we were having with the assistant. And once we have the question, we will send it to the assistant in order to create like the final answer. In this case, we don't want to talk about the pattern. What we want to show here is like we can have like several invocations to the LLM with a single query, right? We are asking something to the assistant, and behind the scenes, in this example, are two, but we can have like multiple calls to the LLMs. This is the only part where I have some sort of a code. Here we have an example about the context retrieval, and here we have two prompts. The prompt is to recreate and reprocess the question, and the second one is the one that will be the assistant itself, the one that has the instructions to create the response. So the first one has received the input, and the output will be a question. So the question then will be forwarding to the QA system prompt, and the QA system prompt will have the context, some context that we want to the context in this case will be information that we are ingesting to the assistant in order to enrich their knowledge. So at the end, in our code base, we will have an assistant and a single process where we are sending a question, but internally we will have like these change mechanisms that we will go through different LLM invocations. Okay, so this is the assistant, a simple assistant with an LLM. We so far so good. Here, this other diagram is overlapping with the latest example, but it's just for theoretical purposes. This one, in this assistant, we have a knowledge base, an intermediate knowledge base. So this information is information that the LLM doesn't know. In some examples, they are related, for example, to where the latest soccer World Cup winner, or where is the current president of some state. that kind of information, or proprietary data of a company. So all that information will be stored in our knowledge base, and then we have the LLM. The LLM will be enriched with this data. In this layer on the LLM, here probably if your client it is not confident to use like a private LLM as GPT, because they will have some complaints about their data. They don't want their data goes to OpenAI or whatever other company. You have the options here, as we saw, to run a private LLM, a private model, so their information is not going outside of their network. I extended too much in the meeting. Just to wrap up, the latest thing that I want to highlight here is like sometimes when you have like a proprietary knowledge base here, clients doesn't want to use like a open public LLM. Sometimes it's confusing when I use public or private. Private could be a proprietary LLM, but it's not public accesses, as for example GPT-4. You cannot download it and use it in your computer. So what we want to avoid here is like, this is the request that we will send to LLM, and here is in the context the company information will be injected, so in order the LLM can process the request with the context and the instructions. So this part is the company wants to avoid. So in order to do that, what we can do is to run a private model in the client network as Llama 2, as Gemma, or whatever other model, to maintain all this information securely in their client network. Okay, very quickly, here when we are talking about this approach, when we have like this knowledge base, we are talking about RAG, retrieval augmentation generation. The augmentation is related to the knowledge base that we were injecting before the LLM. So this diagram comes from LangChain, and here we are seeing like here we have like two main flows. And the first one is when we are injecting documents or information through our private knowledge base. So we need to go through the LLM to convert our text information to embeddings, which the embeddings are the vectors that the knowledge base, the LLMs can process, and we will store them in a vector database. So that is our knowledge base that comes from our information that we have in our company. That information should go through a transformer, through the LLM, so they can be transformed to vectors. And then when we want to interact with information, when we are doing the query, we need as well to translate our text question to embeddings, and the question in order to retrieve the relevant information to create a response for our question. That information will come from the vector database, and then the prompt with the query and with the context will go through the LLM to process and synthesize the response that finally will come back to the user. And so this is another diagram as well. We have the user that asks a question to the system. Here the new thing, or the new concept, is the vector similarity search. That means that when we have the question converted to a vector, what is happening is a similarity search. So we are looking a vector, which is the question, in a vector space. So we are retrieving vectors from we are retrieving embeddings. The embeddings at some point they are translated to text, and all that information will go through the LLM in order to be processed. So here we have an example where we have two implementations. Here it says, what was the name of that movie Chris emailed me about yesterday? So this is the question, goes through LLM, and a system doesn't know the answer because the information comes from an email. So what we can do here is to enrich our assistant with that information. So once we have received an email, the email will go through a knowledge base. So then we can the assistant can say like Chris Thompson emailed you about the file on October and so on. So this is the kind of scenarios that we have with the RAG pattern. And then here the RAG pattern is awesome, but they are having it has like several limitations. So as bigger the context, as complex the context, RAG pattern is not so it doesn't retrieve some detailed information. Typically there's a pattern that lose information, or it's like man in the middle, lose information, man in the middle, but like they are losing detail within the sentence. They are not capable to extract like detailed information of our business model. So here we have like different, these screenshots come from people from Llama Index, which is a competitor of Langchain or LangGraph. And here they are like patterns that we can find within the RAG implementation, where we have routing, memory, planning. We can add tools to our agents. We have like reasoning agentics, where we have sequential, we have direct, we have like direct graph, we have tree bases, and we can include as well, the observability is pretty important in the context of the RAG to understand what they are doing. So the RAG pattern help us like in not so big environments, and they have some limitations, and there are some other patterns that we can use, as for example this one that we are seeing here. Let me show you some of these examples. In this case, what we are doing is to have like a plan and execute pattern, and in this case what we have is this sequence. When we are creating like a plan, the plan is the system will create a plan. The plan, we are asking for a complex task to do, so this first step is what it's going to do is to create like a list of tasks to be done in order to create the response. And the good thing about this is like there are several invocations to the LLM, and these LLMs can be different. So we can use like a more robust or bigger model to create a plan, and then we can use like a smaller LLMs to create smaller tasks, and we can run it in parallel or whatever we want. And then a good thing here is like we have like a final step where we are like replanning and verifying the response. So the system or the LLM helps to review, and it has some reflection about the response and evaluate if we need another task to do or not. So these are like other approach that we have at the time to creating RAG. And here we have like a tree of thoughts where we have the input, and here we have the output. So here we can have like different structures to create like multiple as well. We can have like multiple plans to evaluate in this complex task, and at some point we run it all together, and at the end we will evaluate which response is more accurate to or have like bigger score at some point. So these are improvements on top of the RAG pattern. So we will stop here since it's a lot of data, but just want to, in order to have like a second meeting, then here what I want to talk about is an assistant who has tools. Then we want to go to the multi-agent environment, so we have like multiple agents working together, similar to the latest example that I show you. But here is like a multi-agent environment, and the other one is like a pattern. And finally here I want to talk about like graph database, so changing the knowledge base storage layer. Instead of storing vectors in the knowledge base, we will change it to a graph database. So we can have like a different way to create our knowledge base and have like other more precise responses. So we will stop here, and then we can have another session. So thank you for your time. Sorry because this is so extensive probably, and see you in the next one.